Hey everyone, welcome to 1.4 Part 2, One-Side Limits and Continuity on a Closed Interval. And here is your trivia question. What sitcom centered on kids who constantly frustrated Bayside High principal, Mr. Belding? Alright, so first we're going to talk about definition of a one-sided limit. A limit that as x approaches c from either values less than or greater than c, and it's denoted as limit as x approaches c, and a little plus there, f of x equals L, and that's the limit from the right. And the limit as x approaches c minus f of x equals L is the limit from the left. So the minus is from the left, plus is from the right. Okay, pretty easy to understand, and remember it's just basically taking limits, but now we're doing it from both sides rather than just taking a limit at one time. Alright, so why do we really need to do that? Why is that important? We don't need to know this. Well, kind of, because square roots are really, really helpful, right? Because at square roots, we don't have square root of a negative number if n is an even is not going to have an answer. But we can still take the limit just from the right side. The square root of, or the nth root of x as x approaches 0 from the right side is always going to be 0. So it's one way of kind of doing this. Alright, so let's take a look at an example. Find the limit as x approaches negative 2 from the right side of square root of 4 minus x squared. So what I have done here is I have put on the graphing calculator, and if we graph it, right there it is. Is that the right one? Yes, it is. Okay, so we graph it, we go, and it's like kind of like a half a circle, even though the calculator screen is a little bit off. As we go to here, it kind of stops because it doesn't know what to do at some of these numbers. So the calculator doesn't really help us out. But from there, we're going to say we want to go to negative 2 from the right side, which means we're going to go on this way. We want to know where's that going to be at. Well, it looks like it's going to be 1, 2. It looks like it's going to be 2. So what we're going to do is we're only going to take it from the right side. Okay, so if we try to find this limit, what I'm going to do is just plug in that negative 2 right for that x and see what happens. So if I have the square root of 4 minus negative 2 squared, negative 2 squared is 4. 4 minus 4 is going to be the square root of 0, which is just equal to 0, which is good. We can just kind of use that direct substitution and plug it right in. Now, if we try to take the limit from the right side, we wouldn't be able to do it because we'd have infinitely smaller numbers that are going to make it a negative, and then this is going to be 4 minus something that's bigger than 4, and the square root of a negative number, we're not going to have it work out. So it only works from the right side. Okay, so it works out, and our limit at this point is 0 just by direct substitution. Okay. Are you still not convinced why we should be using limits only from one side? Well, here's another reason. Step functions. We're going to use the greatest integer function, and that just means it's like a bracket with a double bar, kind of like that paragraph P. It's got the 2 lines going down, like that. Same idea, just 2 lines. So this is a step function. It means it's going to be here to here, and then it moves up, and it goes over, and goes up, and goes over, and goes up. Kind of skips that going up phase. All right, so here's an example. The greatest integer of 2.5 is 2, and the greatest integer of negative 2.5 is negative 3, because it all goes to the nearest integer that's smaller, which is that way. Got it? Okay, so here's another example of why this limit might be helpful one-sided. Find the limit of the greatest integer function for the age you can vote from the left and to the right. Remember, age is going up by years. No one ever says, I'm 12.462138889 years old. No one says that. They say they're 12. Right? Or 14, or 16, or whatever. So we're looking at, in order to vote, you want to be at this purple line right here. Let's see if you can see it real well. There you go. And so if we say the limit as x approaches 18 from the left side, remember left is negative, of, let's say, f of x, we would go to that and we'd say, okay, it's at here, so really to the left of 18 is going to be over here, which means it's going to be going this way. We're getting really, really close to 17, right? So if you're 17 and you're going to be 18 tomorrow, and tomorrow's the day you vote, or 2 days from today is the day you vote, and you're going to be 17 tomorrow, you can't vote, right? And so let's try the other one. The limit as x approaches 18 from the right side of f of x is going to equal, now we're going back this way, and we're going to say it's going to be 18. So if you turned 18 yesterday and voting is tomorrow, you're good. You can do it, right? So does this limit exist? As we go from the left side to the right side, there are 2 different ones. They're going kind of like this. There's going to be no limit. Even though we have a limit from this side and a limit from this side, they're not going to intersect. They're not going to the same number, so there's not going to be a limit from both of them, but we can find the limit from the left side and the right side. All right, so speaking of that, the existence of a limit, let f be a function and let c and l be real numbers. The limit of f of x as x approaches c is L, meaning it has a limit if and only if the limit from the left side equals L and the limit from the right side equals L. They have to equal the same thing. So our age function, not going to be a limit, even though we got limits from the left side and the right side. All right, let's now talk about definition of continuity on a closed interval. Definition of continuity on a closed interval. A function f is continuous on the closed interval AB, remember the closed interval is the square brackets, if it is continuous on the open interval AB, so we don't have to worry about those endpoints. We have to check them in between first, and then we can go back to those endpoints. Okay, so it's got to be continuous on the open interval, and the limit as x approaches A from the right side is going to equal f of A, and the limit from B as you approach it from the left side is going to equal B. And then the function is continuous from right and continuous from left at B. So remember, A is the smaller one, B is the larger one. So we want to find this one and that one. As long as they are going to this point, there's not like any jump or removable spots, right? So as long as we can go to those, we're going to be good on this interval. All right. This also works for when you have intervals such as an open and closed. You know, you could have it open and closed. We could have a open this way, A and B, close there, right? It could be 2 to infinity. It could be -2 to infinity, and so on. The infinity is never closed because we can't actually get to infinity, so that way, it's always open. We don't have the square bracket, we have the open bracket. All right, so here's the last one. Discuss the continuity of f of x equals 1 minus x squared. So if I want to say it's continuous, I want to say, is it continuous on the open or the closed interval? So the first thing we're going to do is we're going to look at, is it continuous on the open interval? So what we will do is we are going to look at the equation. So what I did here is I already plugged it in. Oh, and let's just clear this one out. And then if I graph it, there it is. So on the open interval from A to B, it looks like it's -1 to +1. So our interval, let's just do the open interval first, from -1 to 1. It looks as though those are the numbers. Oops. Hey, there we go. -1 to 1. Yep. So that means it's going to be on that interval from -1 to 1. Is it continuous? Well, as I look here, I don't see anything that would have a problem. And if I go back to my equation, I don't think there's going to be anything wrong with it. As I go from -1 to +1, I'm not going to have any problems. So it's continuous on the open interval. Okay, so now let's try the interval when it's closed, -1 to +1, and see if it's still continuous, which means we have to check as I go to the A, the smaller value, from the right, and B to the larger value to the left, does it still hold? So I want to know, is the limit as x approaches the smaller value, -1, from the right side of the square root of 1 minus x squared, do I get an answer? And that would just be substitution. 1 minus -1 squared. -1 squared is +1. 1 minus 1 is 0. Square root of 0 is going to be 0. So that's okay. And then let's do the limit as x approaches +1 from the left side of the square root of 1 minus x squared. 1 squared is 1. 1 minus 1 is 0. Square root of 0 is still 0. So that is going to work, and if I plug those in, I would get those answers for both of them. So that means it is continuous. I'll make sure you can see this. It is, and we'd say that f is continuous, OUS, on the interval from -1 to 1. And we have a closed interval because we did find out that the limits exist from the left side and the right side for both of them. All right, and there we go. And the answer is saved by the bell.